So we are coming to our next speaker. Our next speaker is Fredrik Christensen. And when we asked to say a couple of words about him, he told programming is my life, and I'm doing I'm doing programming all the time when I wake up. So, and also Fredrik got also amazing YouTube channel. So I'm very happy that we are presenting so many YouTubers here. And Fredrik, the scene is yours.
Hey guys, so let's start by sharing my screen. Let's see here, share screen, and there we go. So the tech talk that I'm going to present today is pretty much just about node testing and how I believe that you can succeed with node testing. And without further ado, my name is Fredrik Christensen. I work as a software developer at Mina Technologies in Gothenburg, Sweden. It's a company that focuses on subscription management and banking errands. And well, that's probably all I need to say about that. So today we're going to cover 4 topics that I think is some of the main things that we need to address in order to have a sustainable scaling strategy for our tests. So first and foremost, I'm going to talk about what I feel is lacking a little bit in the node ecosystem today. And I'm also going to talk about test toil. We're going to talk about just slightly about the testing pyramid and some thoughts that I have about the testing pyramid. And then finally, we're going to talk about actual scaling in terms of performance and so forth. So let's dive right in. First and foremost, there is something that kind of makes me a little bit sad when I see, and that is this code here. Now, there's nothing inherently wrong with the code that we are looking at right now, because all it's really doing is that, okay, there's some endpoint. You push some requests to this endpoint. It grabs a user, it checks if the user exists, it creates it checks for a few products, and then it creates an order. That's all it's kind of doing. Now, the problem from a testing perspective with designing your endpoint controllers in this fashion is that this is hard to test. You can't really pick which type of test you want to do here, because if you want to test this, you're in essence forced to spin up an instance of your server and then actually send requests towards that server in order to execute any type of meaningful test. So the first point I want to address is that I believe that in order for you to succeed with testing, and this doesn't just apply to Node, it just, I would say in general is true, is that you need a thought on architecture, because a working test strategy, it starts with a good architecture. Now, there is a few thoughts that I would like to share about this, and this kind of touches on the Node ecosystem. So I will make an argument to you, and the argument I will make is that each community, regardless of if it's Node or if it's Ruby or if it's Python or Java, every community has its own roadmap of tools that new developers are kind of organically exposed to. And so in my test example here, or my code example, I'm pretty much showing you an Express server with a Mongoose interface towards MongoDB. And I feel fairly comfortable showing that as example code, because I feel fairly confident that a lot of Node.js developers will know about these concepts. Now, the thing that I feel is lacking, though, is that there are certain elements to the way that we teach our Node.js developers how to structure their application that, well, they could be better. And there are other communities where certain literature and certain concepts are very organically part of that culture. One such piece of literature is this book here. So Domain-Driven Design is probably one of the most important books that I've ever read that helped, at least for me, made the biggest difference in becoming a professional software developer and being able to write larger scale systems and deal with architecture and so forth. Now, this book here, you may not have seen it, you may not have heard about it if you're coming into Node, but if you are in another community such as Java or C# and so forth, it's very likely that you would have been exposed to this. And I would love it if we could make this piece of literature as a part of the Node roadmap, the learning roadmap, if that makes sense. Another concept that was lacking in the code that I was showing just a moment ago is the idea of a layered architecture. This is also a common pattern of structuring in an application when you're dealing with large-scale, well, it technically doesn't have to be large-scale systems. It can be pretty much any application type. Most of us are actually building our applications in this fashion. So you have some type of presentation layer, which is in our part of the internet usually something like React, Vue, Angular, so forth and so forth. We have some type of application layer, which is the server itself, and then we have some type of business layer or something like that. And that's the thing that was lacking, if you ask me, from the code that we were just looking at, because we kind of skipped that part and just went directly to the persistence layer, because Mongoose is, in my world, a direct interface towards the database, which is the last layer. So let's just walk through this in a simple fashion. And let's start by saying that, okay, let's take all the logic that we just wrote from the controller and just put that into a function. Let's start by doing that. Now, our code will now look something like this. Now, you may think that this is not a big deal, but what's actually happened is that we have created a situation where we have now decoupled the underlying business logic of how to create an order from the actual application layer. This is very powerful because now we can isolate the functionality that we want to test into this function. But we could also just focus on testing the controller itself. And this separation of concerns is the red thread that I want to keep with us through this talk, because these concepts may not come completely organically and natural to a new developer in Node.js, but if you were to be exposed to something like domain-driven design and layered architectures, this will start to make sense, and it will make a big difference when we talk about testing. So the second part of my talk is going to be about test toil, and I will make an argument to you that test toil is one of the most important parts of a developer's life when we want to work with automated testing in any way. And the reason why I argue that is because if you have a bad architecture or you have a lot of excess noise in your testing process, you're actually going to create a situation where you and your team members will find it hard or cumbersome to actually write tests. I don't know how many tests are missed just because someone just doesn't want to go through the process of creating the test itself. Because if it is hard to write the test, it's kind of like brushing your teeth. You know you should do it, but sometimes you forget because you're tired, etc., etc. And I argue that the same thing is true for testing. So let's put our logic inside of a test. Now, this is pretty much testing the logic that we were just looking at. So what we're doing is that we are creating an integration test. We are creating a user and we're saving that user. And then we're creating a product and we're saving that product. And then we simply call the create order function. And then we assert that we have exactly one product. Now, this test could be better, but hopefully you're with me so far. Now, there is an issue, though, with the way that we have structured this code, which comes back again to this idea of an architectural approach to how we design our software. Now, this code is not bad. It's just that it's not very testable. The reason why it's not very testable is because if I do something like this, I'm going to be in a bit of a bind. So I have a new requirement now where I'm not directly just accessing the database and creating an order. I also have a metric service that connects to some external system somewhere out there on the internet. And I don't control that. It's a third-party service or something like that. So I need a way to get at this logic. But the way that I have written this function, well, from the test, it's not really possible for me to get at that piece of logic. Now, I know that some of you who have experience writing tests in something like Jest or Mocha and so forth, and you might think about other libraries such as Rewire, will go, well, it's not a big problem because we can actually mock off the actual module import and go get at it that way. And sure, you can do that, but that's what I argue, going towards more test overhead and creating a situation where you actually add more work towards your testing process. So what I would like to do is to ask the question, all right, what would Java do? Now, why in the hell would I ask this question? Well, it's very simple, because the idea of domain-driven design and having a layered architecture is that you separate your concerns. Now, in a Java world or C#, it's very common to create a concept of a service, and a service can look something like this. So we create an order service, and it takes in a bunch of other dependencies, such as a user service, a product service, and a metric service. And then we have a reference to the order model, so that the order service that is responsible for the order itself can actually deal with the logic of creating the order. So now we can change our code ever so slightly. So instead of directly referencing an import, such as the user model and the product model, we simply depend on some other service that now knows how to get the user and get some products. And then we keep the domain logic of creating an order inside of the create order function. And this creates a much simpler test, because now we can do this. So now we can instantiate the metric service as a mock, and then we can simply stub off the order created function, and then we can assert that the order created function was actually called. So now we don't depend on the external service, and we can still assert that the call actually happens as part of our business logic, which I think is pretty great. But I also think that, as I was saying earlier, there are concepts that make sense in another community, and we can take learnings from those communities, but I don't think that we should copy-paste this solution. The reason why I don't think that this is an ideal solution for the Node ecosystem is because if you go to Java or C#, there's a very strong pattern of object-oriented programming going on in those communities. And one of the worst parts about writing code in this fashion is that if you want to instantiate a service that has a lot of dependencies to other services, well, then you have an object depending on an object, and then you need to instantiate that object, and that may have dependencies in turn. And all of a sudden, you have this cascading effect where you need to write a bunch of boilerplate and stub and mock off things just to be able to instantiate the order service in order to call the function. But in Node, we don't really have a strong adherence to strict object-oriented principles. So I think that we can do something like this. This is one of my favorite patterns for dealing with this, and that is to create a higher order function that simply takes in the functions that I depend on. So this is now the same logic. It's just that here, instead of passing in an entire service that may have God knows how many dependencies, I just pass in the get user function and the get products function. It's just a function with a signature that abides by the functionality that I want. So it's just going to return what I want. And this is the minimum amount of dependencies that I can have in this function. So now our code looks like this, and I think this is pretty nice. It reduces testing toil down to the absolute minimum. Instead of instantiating boilerplate, I can actually just depend on the thing that does the piece of logic or does the thing that I actually want. And this reduces the amount of work that I have to do quite a bit. So in the third section, I want to touch on the testing pyramid. Now, just briefly, let's look at a very simple testing pyramid. There are multiple versions of this, but for this talk, we're just going to focus on the simple one. So the idea is very simple. You have a base layer of unit tests, which are supposed to test a single unit of functionality, and ideally, these are all run in memory, which makes them very fast and cheap. And then you have another layer of integration test that actually connects to a database or a third party or something like that tests a wider range of functionality. And then you have your end-to-end tests at the top, which is usually the broadest test that you have, which are very slow and expensive, as the graph or the illustration shows. However, there is something that I would like to argue, and that is that, well, I'm a web developer, and so when I work with Node, I usually deal with some type of database. Like almost all the functionality that I'm dealing with is tied into some form of database connection, which is an integration test if you really think about it. So this idea that unit tests are faster and cheaper is true if we think about it from the execution perspective, but there's also a few downsides with having the approach that, all right, I'm just going to focus on unit testing. So what I argue is that there's pros and cons with each level of the testing pyramid. So for a unit test, what's really nice about them is that the execution speed is really fast, they're really stable, and so forth. But I will also argue that if you have the idea that you're just going to focus on unit testing as much as possible, as an example with this create order function that we have, well, the test implementation is actually going to be slower than if you just run an integration test. And there's also a risk of false results. Now, if we look at a slight rewrite of the test that we had earlier, so this is now using our higher order function. It's testing toil-wise fairly low effort. This is today an integration test because we're actually doing live calls towards the database. But if I wanted to turn this into a pure unit test, I would have to do something like this. Now, here I'm mocking off every piece of functionality that I have that hits the database. And although this is perhaps useful, it's checking that I'm calling the right functions and so forth, there is an issue with this, at least from my perspective. And that is that if we have a look at what we actually did, hopefully this is going to illustrate an issue. And the issue that I see with this is that the create order function, well, inherently, all the create order function is doing, it's not performing any type of isolated logic. It's basically just a wrapper around a bunch of database calls. In my world, this is inherently an integration test. But since we have the idea that we're going to focus on unit testing for the sake of, which is a very normal argument, execution speed, well, we've actually created a worse test. And the reason why this is a worse test is because the create order function in this test, it doesn't care about any input. Like I can pass in an ID string in an empty array, and since I'm mocking off the get user function and the get products function, they will always return something. So I've actually decoupled the underlying functionality from, it doesn't do anything meaningful anymore. All it's really doing is that it's checking that I'm calling the function. And sure, I could improve this test and say that I expect the get user function to be called with a certain amount of parameters. But I also found myself in a situation where if the get user function, the actual implementation, changes from what I have in this test, well, then this test will still pass and it will still be happy because I've created this mock get user function or get products function, and it doesn't really care what I pass into it. So I'm actually not testing the thing that I think that I'm testing. And I've seen so many situations where stubbing and mocking has gone to the point where it's actually creating a test that always returns positive, even though it should have broken. And then it's a pointless test because it's not actually helping me write better software. So for integration tests, I argue that they have gotten a little bit of a bad rap in some situations because the great part, at least from my perspective with integration tests, is that they are closer to reality. And the test implementation of an integration test is fairly fast once you have set up the boilerplate and the infrastructure so you can spin up a database fairly quickly, right? The downside is, which is the normal argument, the execution speed is slow. And sometimes, yes, you have stability issues, especially if you're running a lot of them at the same time. But what I will argue is that when we are constructing a working testing strategy, it's more important to think about using the right test for the logic that you're testing as opposed to execution speed. Now, execution speed is very important, but in my last section, I want to show you an idea, at least, at how you can address execution speed in integration tests. So the original test that we had, I think this is a pretty good test in terms of, it's just a very nice middle ground. So sure, we are going to trade some execution speed because we need to go to a database, but it took us it's not a very complicated test to maintain. It's actually testing exactly what we want. It's making sure that the get user function is working, the get products function is working, order interface is working, and the only thing we're actually mocking off is that external dependency. And sure, we could make some elaborate solution where we have like a proxy or something like that kind of stubs and mocks that off as well. But I would argue that we are probably as close as we're going to get to reality when it comes to running this in production. So another example of when you want to use mocks with integration test is, in my opinion, that's like the rule of thumb, I would say, that going with an integration test when it's a natural integration test, as in this case, well, we should not try to stub off everything. We should simply use the mocks in order to simulate behavior that would be really hard to simulate otherwise. An example would be the order. So one very reasonable test is, I want to know if something goes wrong with getting the user, what state is my database going to be in? Because that's actually a real issue. If I'm not testing for this and I'm not actually using the database, I don't know what's going to happen in production if this fails. And this is very hard to test if you stub and mock everything off. Now, lastly, I'm going to talk about end-to-end tests. And these are also open for a lot of discussion. So some people swear by them, and some people say that, oh, they're a very big cost to the project. And yes, they are a big cost, but hopefully I can show you some perks about using end-to-end tests, because I truly believe that they are a very powerful thing. I will even go as far as to say that if you have a UI layer, if you have anything to do with CSS whatsoever, you kind of have to use this in some fashion, because CSS can always fail. It just can always fail. If you can make a single rule change the fact that you can't click on certain buttons and interact with certain elements. So what I argue is they are closer to reality, and what's really nice about them is that they work at the view layer. But these are, of course, among the slowest and most unstable tests that you can have. Now, some of you may know about modern tools for this sort of testing, which is, I think the favorite these days is going to be something like Cypress, or maybe using something like Puppeteer, or I think Playwright is also fairly popular. Now, what I would like you to take a look at is these two tools. So I used to use Cucumber.js for the longest time, and now I'm moving more towards Concept.js. And the reason why I like these tools is because they are practically allowing me to do all the things that I'm already doing through automated testing. So I can just write automated tests if I want, but these are forcing me into a very specific workflow, which is a workflow that I absolutely love, and it's called behavioral-driven development. So BDD has, I think it's one of, at least in my opinion, the best patterns to follow if you want to be successful with end-to-end testing. The reason is because BDD allows me to do something like this. Now, for those of you who have never seen this before, this is a Gherkin file, or well, it's a feature file written in Gherkin, and that's just a pseudo text language that allows me to express a feature and a scenario, and then I can actually express different statements around what I want to happen when I execute my test. And what's so powerful about this is that this is just a text file that I write, and then in this case I'm using Concept. I can use Concept to generate this, which is implementation steps in order to execute the logic that I just showed you. So in this case, we're going to go to Google search page. We're going to search for something, and then we're going to click the search button, and then we're going to expect to see, in this case, cats. Now, the reason why this is so powerful is because this is actually allowing me to have the closest thing to live documentation. I mean, I have had such great results with this. I really am excited to tell you about this, because it allows you to state what a feature should do and when you're done. And on top of that, it allows you to use the closest thing to automated, well, it's live documentation. It practically is live documentation. And on top of that, the more people from your team that actually add steps, the less code you have to write, because you have different plugins and so forth that can help you. So when you start writing out a feature file, you'll get just auto-completion on a bunch of different steps that somebody else has already implemented. And this makes it actually is a massive exponential return on investment, where the more people writing tests, the less tests you actually have to write yourself from scratch. You can simply reuse the steps somebody else has created. Now, one thing that is really bad about end-to-end tests is that they probably need more state than any other test that you're ever going to run. And what I mean by that is basically, as you can imagine, if you're actually spinning up like a headless browser, well, a real browser, doesn't really matter if you're running Selenium WebDriver or Chromium or whichever, right? You're actually forcing the browser to go through all of the interactions that the user is going to do. And if you have already covered the case of something like logging into some type of web shop, well, if you need to go to the order checkout page, you're going to have to rerun the logging steps over and over and over again. And that is going to slow you down quite drastically. So here I argue that there is a more pragmatic approach. You can, of course, just run everything from scratch every single time and just go through the purchase flow every single time for every feature. That's going to take more time. And if you're fine with that, go for it, because it's the most realistic thing that you can do. But you can also short circuit it a little bit. And something that I like to do when I'm concerned with the execution speed of my end-to-end test is to do something like this, to create a state builder. Now, a state builder is just a builder pattern where I have an array of commands, and then I create these helper functions that allows me to create the different entities within my database that I actually want. So in this case, I want to be able to create a user, and so I pass in an object that just takes a bunch of default arguments if I'm not passing in anything that I want to override, and then I push a function that knows how to save to the database to my commands array. And then I have an execute function of some sort like this that just goes through all the commands that I have chained and then executes them one after the other and then returns the results. So I can create some setup code for my end-to-end test. It doesn't have to be an end-to-end test. This will work in more patterns than this. But this allows me to very quickly just stub up a bunch of state into my database, so I can skip the process of forcing my test to just go through the same processes over and over again, such as creating an order and then checking out and so forth. So I can kind of just skip to the part that is relevant for my test, as long as I'm sure, of course, that I've already covered that in some other test. Now, lastly, I promised you to talk a bit about scaling your test. And that's the thing that I want to make, hopefully will make a lot of sense to people, and that is that I argue that if you're concerned with execution speed on your test and you focus on unit testing for the sake of execution speed, I think that there is a better way. Because the thing is, a test is a cost that you are paying, and if you want a return on investment on that cost, you have to make sure that that's a quality test. And if you stub and mock everything, you're not ever going to be completely certain that everything is going to work, because you're too disconnected from the reality of things. And I will even tell you this, although it is true that a unit test will execute faster than an end-to-end test or an integration test, it's just a matter of time before you have enough unit tests that's going to slow down your process anyway. So thinking about a scaling strategy, even when you're just doing unit testing, is a good idea. So what I like to do is to have the learnings from domain-driven design and a layered architecture with me and structure things in a modular fashion. So in this case, I'm just adding my tests to my different modules. So I have an order module, a products module, and a users module. And then in my package JSON, I can do this. So I can segment the different types of tests that I want to execute. And this is just for unit testing now. So now I can run all the tests, or I can run the orders test, or the products test, or the users test. Now, when I'm working in a local environment, it's rare for me to want to execute all my tests unless I really don't have all that many. I usually just focus on the tests that I'm writing. In a CI pipeline, it's a different story. And you mean we can take this even further. We can do something like this, where we can just segment on more things than just this is a test. So here we segment on what type of test as well. And then that leads us to something like this, which I think is pretty nice, where we can actually segment out unit tests, and we can even segment out on line 2 here. You'll see that I've marked the regex there was stating that, okay, there are certain unit tests that are so-called like heavy unit tests, which is something that I also like to do, because some tests, even though they are unit tests, well, they're going to be heavy anyway. An example would be if you do testing in, say, React or your visual components, you'll know that some components have animations and stuff like that that are forcing a delay of some sort, and you can also just fork that off into a separate process. And then I have integration tests.
Fredrik, 5 minutes.
All right, 5 minutes. Thank you. I'm on the last slide in a minute. So finally, basically what I want to say here is that instead of having this idea that you're going to optimize for execution speed when you're writing the tests themselves, focus on writing good tests. And then when you're actually pushing code to a CI pipeline, you can segment the execution like this and simply have multiple boxes executing all these tests in parallel. That way you can maintain your execution speed without worrying so much about the quality of the test. So to summarize, what I want you to take away from this is pretty much that if you structure your code well and have a good eye for architecture, your test will benefit. They will become much better. Keep it simple. Like, the simpler you can make your testing strategy, the better, because if it's hard to write tests, it's not going to happen. And then pick the right test for the problem. Don't focus too much on if it's a unit test, integration test, or an end-to-end test. Figure out what the problem is that you're trying to solve and pick the right test accordingly. And then finally, segment your tests so that you can run the work in parallel instead. And that way you can actually maintain execution speed even if the code keeps on growing. And this is true for all types of tests, not just the slow ones. So yeah, that's pretty much all I have to say. Hopefully you found this useful.
Thank you, Frederick. That was an amazing presentation.
Thank you.
There is a lot of discussions in our public chats in Pine. So also, please, all our listeners, remember that you can ask questions in our Q&A section, and we will be discussing them on our Q&A section. Yeah, actually. One of the comments for you, Frederick, absolutely brilliant. So congratulations. Also, I would really enjoy your YouTube channel. So definitely we will share the link to your YouTube channel so you'll have more subscribers who will be watching your interesting lectures. Thanks a lot. So our next presenter is preparing. And before that, I would like to say a couple of organizational moments.